Welcome to day 10 Arduino lab class. Today we are going to see 7-segment display. Before that, we will recollect what are the things we have seen in the last class. Then we will come back to the today's class session. So actually in this class, we are going to see two type of LED 7-segment displays are available. The common cathode and common anode. But even though we are having two types, we are mainly going to focus on common anode because this is the setup we are having in our lab session. Okay, so last class we have seen two things. One is the temperature sensor and is the PIR sensor. You may ask why in between we included the display means. In many of the sensors, you will find some values. All the time writing the LCD program will take much time. So if you use the 7-segment display means simply you can want to display some count value means immediately you can display the counts. So for the purpose only we include the display in between. And last class, wait a minute. Yes, last class we have seen two things: how to interface this TMP36 sensor and the PIR sensor. So in the TMP36 sensor has three terminals. So by the temperature from the external environment, we displayed the temperature value in degrees Celsius and Fahrenheit in the serial monitor display. For this sensor, the temperature range is from -40 to 125. This range will vary to sensor to sensor. So whenever you buy the sensor, please go through the data sheet, then you start program it. Okay. Then passive infrared sensor. It is a one type of infrared sensor. So using this, we detected some motion around the sensor. Once the object is detected, we made some alert in our serial monitor display. Okay. So with this, we will come to our day 10 class. So here, very simple. We are going to interface 7-segment LED display. The hardware is very much familiar to you. You may did the number of experiments in your electronic devices laboratory. With this, we are going to do two experiments. First, we are going to focus on to turn on and off every segment on a 7-segment display. So I am going to turn on and turn off the every segments in my 7-segment display. So I am having 7 segments. Start from A, B, C, D, E, F, and G. Okay, so all the segments, including I have one decimal point. So, okay, if I want to create any decimal point, as like in the top slide, the dot you have to put it means you have one decimal point also available. So all the things are nothing but an individual LEDs. So all are fabricated in a single package. The second experiment, we are going to start from 1 to 9, that we will see later. Okay. Now please observe this animation. What we are going to do in the first exercise. Please observe once again. Yes. So in this fashion, I am going to turn on individual segments one by one. Then after some time, I will make all the segments to off. So this is an hardware setup. As sir told already, here I am going to use the segment pins, segment A from pin number 2 to 8. The last pin is for decimal point. If you want to make a decimal point to work, we will add one more pin, or else we can skip that one. Okay. So for that, what is the program setup? Just now you have seen. Very simple. You need to configure the pins as output. Then by default, we will make all the digital pin to off state. So since I am going to use common anode, I'm going to use the common anode in my experiment. See, this common pin I have connected to the VCC. So this is common anode setup. So if I want to make all the segments to off by default, I'm going to pass the logic value as high. Please observe here. Why it is high? Since I'm going to use the common anode 7 segment, if I pass high in all the pins, then only all the segments will get turned off. This you will check it now. Okay. So this is in void setup. In loop, simply I'm going to turn on the each and every segments. So turn on means I need to pass logical low because it is a common anode segment. After some time delay, I will turn off one by one by passing the digital write command of logic high. Okay. You will try this one in the simulation. So after some time, we'll give some delay. Then it will come back. This loop will continues. Okay. Now you come here. Go to Tinkercad. Sir, is it visible, sir? Shall I continue with this?
Yes, sir, it is visible.
Yes. Okay. Thanks, sir. Thank you, Ram, sir. Yes. So from where I need to fetch the 7-segment display? 7-segment display is an input device or output device. Can you type it in chat box? 7-segment display is an input device or output device? Obviously, it is an output device. Very good. Then you come down, check it in that output menu, whether we are having, see, output starts from LED, RGB. Where is my 7-segment? Yes, here I have 7-segment display. So since it is a new component, we will go through the pin terminals of this one. Then we will continue the remaining things. First, see, as I told already, you have a 10 pins. So top, you have 5 pins. And bottom of the segment, you have a 5 pins. Okay. So the labels. So pin number, actually, this is pin number 1, 2, 3, 4, 5. Then 6, 7, 8, 9, 10, like that. We are going to count the pin numbers. The segment names are clearly given in this Tinkercad software. See, if I bring it nearby the segment one, it shows it's E, then D, then common, then C, then decimal point, then come up B, A, then common, then F, then G. Okay, so these are all the pinouts of the 7-segment display. Okay, then you can observe one more thing. See, here I have one drop down option. If I drop down this, here I am having 2 things. Whether I am going to use the common anode or common cathode. Okay, this is user option. If I want to select any one, you can select it. Most of the experiments we are going to deal with only common anode. The reason behind this is the hardware setup, what we have it in our class, in our laboratory session is the common anode display. Okay, let me show common cathode only once, then we will come back to common anode. See, for example, if you are buying the 7-segment display like this from the store, how to check whether my 7-segment display is working or not? Because there are 10 pins I need to connect. If I give all the connection, at last, if I find any one segment is not working, it is not fair enough. For that purpose, how to test it? See, there are some test setups. See, if you take this 1.5 volt battery, in most of the cases, we will use this 1.4 for testing voltage. Okay, see, LED, the typical, see, all the segments are fabricated with the help of a LED. The typical voltage of LED, the forward bias voltage of the LED will start from around 1.3 to 2 volt. It depends on the type of LED manufacturer will give you the data sheet. In that you can go through it. For example, wait, I will show you one data sheet for your understanding purpose. See, this is the simple data sheet of 7-segment display. Actually, this is not an actual display available in the Tinkercad, because in Tinkercad, they didn't mention any part number as like a temperature sensor. Simply, we will see this data sheet. See, likewise, they will give a data sheet. In that, they will mention all the things. See, this is high intensity red, low current 7-segment display. What is the red indicates? This segment can capable of giving the color only red color. Okay, why red and different colors? That is the chemistry behind it. If you know that very well. Now we will see only the required things for us. See, say example, here they have a 3 pots, 3 different pot they have, that is 3 different variants they have. In that, they given the color, then light intensity. See, what is the output we are getting from the LED? For our point of view, we are going to make the segments so simply on and off. But in some cases, the user will give how much intensity they want, luminous intensity. That you need, accordingly, you need to select the hardware unit. After that, wavelength. These are all very basic physical things. Now we will come to our electronic voltage and current parameters. See, they here simply they given forward voltages typically from 1.8 volt to 2.4 volt. For this 7-segment LED, the forward voltage, what is the range? Forward voltage must be 1.8 to 2.4 volt is the minimum and maximum. Then immediately they given whether it is a common anode or common cathode type. Okay, in this way we can find the voltage specification. Current specification, voltage specification are also given in detail here. See here, the reverse bias voltage. If I make the LED to reverse bias, what is the maximum voltage I can give? I can give only maximum of 5 volt. If I give a beyond this volt, the peak inverse voltage won't withstand, the segment will get damaged. What is the forward current? Please observe. The forward current, DC forward current per segment. So individual segment, 10 milliampere is the typical. But peak forward current, I can go up to 50 milliampere. Likewise, you have to start read the data sheet. Then in the data sheet itself, they will give lot of things. See here, I have a group of standards. They have what is the minimum intensity, maximum intensity. Then this graph will give to speak lot. In that, here temperature versus forward current. Then this is the luminous intensity versus angular displacement. In that, we need main chart is this forward voltage versus the forward current. See, if I give minimum forward voltage, I will get minimum forward current. If I keep on increase the forward voltage, my forward current will get increased. This in turn, this forward current in turn will make the intensity too high. Please observe, if I increase the forward current, my intensity will get increased. Okay, this is the theory behind that. Then what is the pin configuration? Here, the pin numbers are arranged side by manner. But in Tinkercad, what we are having in our real is up and down. Okay, for this you have to fetch some other data sheet. So how to test this one? Okay, so far it is clear. See, try to have a practice of reading the data sheet, then start do the actual hardware experiments. Okay, here, see, this is an common cathode. Can anyone type it in chat box? In common terminal, what I need to connect, whether I have to connect plus or minus. Can anyone type it in chat box? In common terminal, whether I have to connect positive or negative. Please type it in chat box. The type of 7-segment here it is. I will show you once again. Common cathode. What I need to connect? Please type it in chat box. In common terminal, we need to connect negative. Since it is an common cathode, I am going to connect the negative terminal into my common terminal. That's all. Now, the positive terminal, since it is a 1.5 volt, it won't damage your individual segments. So without current limiting resistor, I can connect it. So as per pin number, we know this is my segment A. This is my segment A. Shall we check the segment A is working or not? Start simulate. That's all. The intensity may be too low because we are applying very limited voltage and current. Therefore, it gives the low intensity. Okay. So A segment is okay. If I want to change and check it, bring it to B and start simulate. Yes, B is working. So likewise, you can change the wires and check the individual segments whether it is working or not. See, now the decimal point. Now I made decimal point to glow. Okay. So whenever you start the experiment, first check it. Even the multimeter, you can check this one that we will show you whenever you come to the laboratory session. See, this segment is working. This segment is working. Now I'm going to check E. Okay, E is also working. Now we keep it F. Yes, F also working. Now change it into G. That's all. That means my 7-segment LED is in good condition. I can use it in my real project. Okay. Simply what I'm going to do, I'm going to change hereafter. Please listen. Hereafter, we are going to discuss only common anode display. Okay. Common anode. I'm going to change it into common anode. What type of hardware arrangement I need to change here? I changed it as a common anode. What I need to change here? In common terminal, what I need to connect now? Can anyone tell? Can anyone tell? In common terminal. Previously, we have connected negative. Now, what I have to connect? I need to connect positive. Very good. Now, we will change. Now, we will change these two alone. Now, we will change these two alone. Now, I am going to connect positive. Positive in the common terminal. Then, I am going to connect my negative terminal. We will check only 1 or 2 segments. Then, we will start the real experiment. See, A segment is working. Yes, good. A segment is working. Now I am going to change it into B and check. Yes, B also working. So in this fashion, you can check the 7-segment display with the help of simple test voltage. If you are having any WSL, simply you can connect, because it won't give much current. It won't damage your 7-segment display. Okay. Without any current limiting resistor, you can test it. Now we will come to our actual experiment. Okay. Yes. Now we will do one thing. We will fetch the components required for our today's experiment. Please observe what are the components I need to fetch. Arduino board, current limiting resistors. If you are using 7-segment, 7 resistor. If you are including, if you want to check decimal point, you need to add one more resistor. Okay. Yes. Come back here. Fetch the resistor. Yes. That's all. Then what else I need? I need breadboard. I need breadboard. So far, if anyone having doubt, please type it in chat box. Then my Arduino board. That's all. See, now if you want to fit all the components in a screen exact manner, means please click this icon, zoom to fit. If you click, every component will fit into perfect view. Okay. So see, 7-segment, it is a working function. The principle of operation, everything is similar to your PN junction light emitting diode. Okay. So what is the value of typical resistor? We will put it for LED. Can anyone type it in the chat box? What is the value of the resistor? We will put it for LEDs. What is the value of the resistor? 220 ohm?
They are typing 220.
Yes, sir. Okay, thanks. 220 ohm. So let me change the resistor value into 220 ohm. 220 ohm. So 220 ohm, in turn, it will limit your current flowing through the individual segments of your LED. Okay. If I increase the LED resistor value, the brightness will get decrease. Okay. So here I am going to use this resistor to limit the current flowing through the individual segments. So I need a number of resistors. So I am simply going to make Control C and Control V. No, it is not mandatory. Whatever the connection we are giving in the same fashion you need to give. It is your choice. Yes. So I see, if this is the first time I'm going to do the experiment. Let me add this decimal point also. So therefore, I included 8 resistors. Okay. Now you check before start giving the connection, check whether I have using common anode or cathode. I'm using common anode. So as usual, we will power the breadboard first. We'll power the breadboard first. Give 5 volt. Okay. Then ground. Then ground. Yes. Now, so this is common. This is common anode. Common anode means this common terminal. See, we have two common terminals. These two common terminals are internally connected. Either I can give the connection here or here. It is not mandatory. I have to give the connection both the terminals. Okay. So here I am going to give it in this terminal. I am going to connect it in VCC. Why it is in VCC? Since it is a common anode, the common point, I am going to connect it in VCC terminal. Then we'll start give the connection one by one from the segment point of view. Okay. Actually, this is my A. This is my B. Then where is C? This is my C. Then D, E, F, G. Why I need to bother, or why I need to focus on segment order means based on that order only I am going to configure the pin numbers. Whenever I pass some value in the particular digital out pin, it must match with the segment. Then only I will get the record output in the segment display. Okay, so let me follow one fashion. Let me start from here. This I am going to connect it in segment A. Where is segment A? This is segment A. Segment A. Okay, segment A. Then segment B. For better understanding and visibility, I am giving individual colors. Okay, if you want to follow the same thing, else it is not. A, B, C. Where it is C? C is in the near. This is my C. Okay, this is my C. Take another wire. Wait a minute. Yes. This is my C. My C. Then D. This is D. Okay. So A, B, C, D. We have finished. Okay. Then after D, I need to connect it in E. I'm going to connect it in E. After this, I'm going to connect it in E. Yes, E. First time only it will take little time. Okay, thereafter, then E. Where is F? Please check here. This is my F. This is my G. Okay. So A, B, C, D, E. This is F. This is my F. Then this is my G. Okay. What is the only one terminal left? Common you don't bother because we have connected common already. The last one is the decimal point. So decimal point is optional. If you want to use it. That's all. That's all. So please check once. This is the starting pin A. This is A. The second one is B. Then C, D, E, F, and G. That's all. So all the segments are connected in the one end of the resistor. So obviously another end we need to use it to connect it to our controller unit. Okay, now I'm going to connect the digital output pins. The first pin, as per our design, I am going to use the first pin as a pin number 2. Pin number 2. So pin number 2, it is connected in segment A. Please observe this single segment alone. Then remaining things will be very easy for you. See, one of the is connected to the resistor, another end is connected to the A segment. In this fashion, I am going to connect one by one. Okay. Then take pin number 3. Then take pin number 3, connect it here. That's all. Then 4. So single time, if you make the connection, you can have this reference for the further projects. Okay, the first time only it will take little time. Thereafter, you can use the same hardware setup for the remaining experiments by taking duplicate of this one. Okay. So 4 segments successfully we have connected. What about the remaining? We'll start from 6. Okay, only three more terminals. Please recollect your program portion. Be ready. You are only going to give the program. I am going to use it. Okay. I am not going to type the program. Yes, that's all. The last one. Last. Yes. That's all. Only decimal point is remaining. That's all. Is it clear? Is it clear? Yes. Now we are going to start write the program. See, if I give any wrong connection, I will show you that what are the possibilities to get this 7-segment LED to damage. Okay. Now you come to the program portion. Continue. Yes. Tell me what I need to do. Initially, I need to configure all the pin numbers into an output pin or input. Output pin or input pin. Please type it in chat box. Initially, yes. In void setup, I need to write all the pin numbers as an output. I'm not going to individually declare that. So for that, I'm going to use one for loop, integer. The variable name, let me give it as a segment pin. Okay. Segment pin starts from pin number 2. Okay. Segment pin is the variable I have declared. Segment pin starts from 2. Then how long the for loop has to run? So here we have connected up to pin number 9. So what I can do, if it is less than 10, then again, every time it need to increment it by 1. So segment pin plus plus, that's all. That's all. Within the loop, what I have to do, I need to write digital write off. I need to write digital write off segment pin high, then pin mode, segment pin mode, segment pin, comma, segment pin, comma, output. So I configure the pin number as an output. Then I'm going by default, since it is a common anode. See, please observe all the time digital write pin number, digital write of pin number is not equal to low. In this case, it is high. Why? Since I am using common anode 7-segment display to make all the pins to low, I need to give logic high. Please remember. Okay. So based on the hardware configuration, I need to write this logic level. So common anode, all segments, I need to make it into low. Okay. Here, all the segments are made as output pin. Immediately come to our loop portion. In loop portion, what I need to do? In loop, I need to make the individual segments to on for some time. After some time, I need to make all the segments to off. Okay. So for that, I am going to use the same for loop, same iteration. I am going to use it. So here I am going to skip the pin mode. Instead of that, we are going to use to turn on all the segments, or one by one we are going to change. Okay. Here I am going to make one by one I am going to make it on. Okay. So one by one in this for loop iteration it will come. For that, to turn on the 7-segment LED, what logic I need to pass in this argument? It is low. Very good. Please observe. We made all the pin number to output mode. Then by default I made it into high. Thereby all the segments will get turned off. Then in void loop, I'm going to initialize the same for loop, and I am going to pass the logic value as a low one by one. Then I need to give some time delay, because if I won't give any time delay, we can't view the logical change. Therefore, I'm going to use some delay. Let me keep it as a 0.5 seconds, 21 seconds. That's all. If I run this program, what will happen? It will make all the segments to turn on. Let me check this one first. Okay. Start simulate. Come to this window. See, one by one, I am making the segments to turn on. Perfect. Now what I need to do? I need to turn off the segments in the same sequence. That means what? Stop the simulation, go to code window, make the copy of this, and only one logical change I need to do. Instead of turn on individual segments, I need to turn off. Turn off means what? Introduce here logic high. That's all. Okay. Then the overall function, I need to give some time delay. After that, I need to start the loop, means give some more delay in the outside the loop. Okay. Please go through the program. If anybody have the doubt, please type it in chat box. So this is to turn on the individual segments. This is to turn off the individual segments. Now I'm going to start simulate this one. Observe. Yes. 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 A of, B of, C, D, E, F, G, decimal point. Now you can realize that why we are following the pin numbers order. Okay, in the same order only we are going to pass the logical levels. Is it clear for everyone? That's all. I will show you only one thing, then I will wind up, then we will go to the second exercise. See, what are all the mistakes you people will do means, see, instead of connecting the resistor in series, see, you will give all the connections perfectly, but you will connect both the input and output terminal in the same node. If I give like this, if I start simulate, see, please observe, what is this indication represents? The current through LED is 64.1 milliampere at present. What is the rated current they have given? The rated current is 20 milliampere. 20 milliampere. Okay. So for the 20 milliampere only, we have decided that resistor value. This is the one mistake. The another thing, uh, there now I will change the connection perfectly. Then I will check. The one more thing what you will do means this one, the resistor value. The resistor value, if you keep it very low value, let me keep it as 100 ohm and check. See, in this condition also, now see the current slightly higher than your rated current. It is not too high, but even though it is higher than your recommended current. So based on the data sheet, please choose the resistor value. Here, simply we are going to replace it with the values, but in hardware component, if it get damaged means you will lose your money also. Okay, that's all. So the same circuit diagram, only this portion we need to do it. Please observe. Yes. So continuous count from 0 to 9. Okay. It's up count or down count? Can you type it in chat box? It's a up count or down count? Up count. Up count means low value to high. So 0 to 9. Why 0 to 9? I have only one digit display. That's why I limited to 0 to 9. Okay. So now the program portion, you may aware of it. I'm going to store the pattern values by default in my array. Then I'm going to fetch one by one. Then I'm going to make the display value to display in my 7-segment display. Okay. Now the hardware portion is very simple. The same circuit diagram we are going to use it. The pin numbers also same. Therefore, no change in the void setup. In the loop portion alone, we are going to increment the particular row and columns. Then we are going to pass the value into the individual digital output pins. Okay. Come back here. Let me do one thing. We will take only this array portion. See, this is our existing diagram and the program portion. So here what I am going to do is, here I am going to simply copy this segment patterns by default. This you have to work it out. Okay. If it is an common anode and common cathode, accordingly you have to write this pattern. See, first I need to make logic 0. Logic 0 means at the time my all the segments except this middle one, G, has to be off. So accordingly I made the patterns. By default I made it all the values into 0. That means A, B, C, D, E, F, everything will turn on. Okay. The last segment alone will be in off condition. If it is a common anode, what will be the common cathode? What will be the pattern? Can anyone type it in chat box? If I want to make the display into 0, if it is a common cathode display, what may be the value in the first array? Can anyone type it in the chat box? Yes, very good. See, 1, 1, 1, the last one will be 0. So easily you can write the pattern. So here we have shown the decimal numbers. Even you can make the alphabetic value to print in the 7-segment display. For that also, initially you have to do some paperwork, as sir told already. Once you made this, the remaining portion is a simple C program. Okay. Now we will come to the below void setup. So in void setup, here we are not going to use the decimal point. So let me decrease into less than 9. Okay. If I put less than or equal to means, here I need to reduce into what? Here I need to reduce the pin into 8. Okay. So Simply I'm going to push less than symbol. So I'm going to stick with 9. Previously, since we have used decimal point, I have included 10. So void setup, no change. I'm going to make all the segment pin to output mode. Then by default, I'm going to make all the things to low. Now we will come to the main program or the loop portion. Okay. In this loop portion, what we are going to do, the first one, I need to initialize few variable name. Okay. Here in the loop, we are going to declare two variables. One is for pin number, another one is for row. That row variable only we initially we declared as a pin. Okay. For little more clarification, we are going to make the variable name as row. Okay. Yes. What is the first condition? First one, before start passing the segments, I need to start point the first row in my character array. First row. Okay. First row, the address of the row is 0. So for that, I am going to write one for loop for the variable name row equal to 0. What it means? Equal to 0 means what? First row. Okay. Then how many rows are there? How many rows are there? There are 11 rows available. So if it is less than 11, that means up to 10. So 0 to 10 is nothing but 11. Okay. So less than 11. So first row 0 correspond to 0 digit. Second row correspond to digit number 1. Similarly, third row, fourth row, fifth row, up to how much I have? Up to I have 10. So the 10 is what? So see 11. The 11 is nothing but all segment to turn off. Okay. So the first for loop, I'm going to bother about the rows. Okay. One by one, I'm going to increment the row. In first, I will come to first row. Then I will pass column wise value. Once everything is finished, I will come back to the second row. Then I will pass all the columns. Then third row and so on. Okay. So first row less than 11. The increment, every time I need to increment it by 1. So row plus plus. Point number 1 over. So the iteration, this for loop will take the iteration of my my row into 10 times, so 11 times, 0 to 10, nothing but 11 times my this iteration will come. What about the second one? See, please observe here. Here also we made one thing. What for this iteration we made? This is for individual pin numbers. What for this? This is for individual pin numbers. Let me take the same thing. Same loop. Instead of the segment pin, I'm going to keep it as simply pin. Okay. Simply pin. That's all. Pin. How many pin numbers are there? Pin number from 2 to 8 only we are going to consider. Okay. Therefore, I am going to change this value into 9. So 2 to 9. That's all. What for this for loop? Actually, this for loop, I am going to make use of two things. The same for loop, I am going to use it for a pin number as well as the column number. That is the trick behind it. How I am going to use the single variable for two things that we will see here. Come down. Now what I need to do? I need to make the pin numbers to here. It is not a fixed logical level. This logical level hereafter depends on the value stored in our array. This array. Please take this one. Please take this one. According to the array value only, I am going to do it. See, I am going to close the loop. Let me delete the remaining things. And one more thing, in between, as usual, in between, you want to give some time delay to visualize the output. Therefore, I am introducing one delay. Here you watch closely. array for as per our iteration. First time row 0. See here, first row means it will be 0. Second time 1. Second time 2. Likewise, it has to increment 1 by 1. That's all. For that, I am going to simply give the row value here. So row portion is finished. Okay, row portion is finished. What about the column? Please check here. First time in the I want to display 0 means I will be in the first row. This row variable will take care of the first row. Then I need to pass the column value one by one. What is the initial address? Initial column address is 0, isn't it? Initial column address is 0. How I can make this into 0? Is it I want to include one more variable here? No need, because see here I am having the variable name called pin. This pin variable, actually this pin variable, I am going to use it to increment my pin numbers from 2, 3, 4, 5, 6, 7, 8. Likewise, I am going to increment the pin number. For the purpose, I use this pin number with the value of 2. Why it starts with 2? Because the pin number starts with 2. Here, I am going to minimize one variable by using the same pin variable. Can anyone help me to make this value initially 0? What I want to do? Can anyone type it in chat box? See, initially my row is 0. No issue. I will come with first row. And I am not going to introduce one more variable for column. I'm going to use the same variable because I can reduce some memory space. Okay, if I use the same variable, I can save the memory space. So pin number here it is initially 2. If I do some mathematical calculation or manipulation, I can make this into 0. Can anyone help me? What I want to do? Very good. Pin minus 2. That is the idea behind that. See, pin minus 2. That's all. Now you check your program once. First iteration, please listen. First iteration, row 0. Okay, then inside for loop, second variable pin 2. So in this point of time, let me type the first iteration here. Row equal to 0. Row equal to 0. What about here in the first iteration? Pin equal to 2. Okay, so these are all the two variable values. I'm going to pass it in this argument. See, observe here. Here, pin number in first iteration it will be 2. First segment, A segment. Then number array, the row value initially 0. Column value is also 2 minus 2. It will become 0. Then this inner loop will alone will run for 7 times. Okay, to make individual segments to pass the value. For individual segment, I am going to pass the value. Once this inner iteration finished, that means once this condition false means we will come back to the outer loop. At that time, row value will become 1 simply. Then pin number, always initially it is 2. Therefore, I will come to the second row. See, likewise, we are going to use this program and we are going to observe the output. Do you have any doubt? Please type it in chat box. We are going to start simulate this exercise. If you understand this exercise only, you can finish the today's task. Okay. Check number of brackets opening and closing. So one closed. This is for loop. So void loop, I need to include one more braces. That's all. Shall we proceed? Do you have any doubt so far? Is it understandable? Why? See, the simple thing is how effectively we are going to use the program using. Here today we'll learn how to store the two-dimensional array. Two-dimensional array. If we are having only one-dimensional array means here we will have only one square bracket with the some value. Okay. Shall we start to run the experiment? Yes. Start, simulate, and observe the output. Wait, there may be some mistake. Number of array pin segment row 0 pin array. Yes, we will check once. Old program தான் ரன் ஆகுது கரெக்டா? இதனால ஸ்டாப் பண்ணுவோம். அரே நம்ம குளோபல்ல டிக்ளேர் பண்ணியிருக்கோம். வாய்டு செட்டப்ல என்ன பண்ணியிருக்கோம்? ஃபார் லூப் அவுட்புட் ஹை. ஓகே. ஹலோ ஹலோ ராம் சார்.
சொல்லுங்க சார். கஜேந்திரன் சார்.
இல்லை ஒன்றும் இல்லை யாரை கூப்பிட்ட மாதிரி இருந்தது. ஒரே நிமிஷம் சார், செக் பண்ணிக்கிறேன். ரோப்பின் ஃபார் லூப் ஓகே. இந்த டிலே இங்கே இன்டர்னலாக போட்டதுனால என்னாச்சுன்னா எவ்ரி டைம் செக்மெண்ட் முடிஞ்சோன்னு ஒரு சின்ன டிலே கொடுக்கறனால நம்மளால வியூ பண்ண முடியல. சி the delay must be outside this loop. Please observe. This is the mistake we made. First I need to pass all the values, then only I need to introduce the delay between the digits, not a segment. Actually I made the delay between the segments, that's why it is gave the error. Okay, now you see, now it's perfect. 0 1 2 3 4 5 6 7 8, then off, then 0. Please observe, off and 0. How we are achieving off? Can anyone tell how we are achieving all segment to turn off? Come back here, observe this line. If you pass all the segment into 1 1 1 logic high, what will happen? All the segment will get turned off. Okay, any doubt so far? Please tell me. Go through the program once. Actually initially I made this delay inside the loop, so every time it makes the segment to print, at the time it is making delay. Okay, so you can't view the realistic output, so the delay must be outside the for loop, then only you can see individual digits. If you put it inside, you will check only the individual segments increment. Okay, yes. See, is it only one digit is available in this universe? Means not like that. See, this is a 7-segment digit LED display user manual. We found it from the internet. See, if you check this internet in this this PDF file, in that, see, these are all the different types of 7-segment display available in the particular brand. So these are all single digit display. Then you have a double digit display. In the single digit display, please observe what is the change. Common anode, common cathode, common anode, common cathode. Then what else? The size of the display. The size of the display in inches and mm they give. So according to your requirement, you can use it. I think in our lab, in our college, we have this 4-inch also. Okay, if you want to do experiment, come to college, at the time you can check. Okay, this is two digit display, double digit, 3 digit, 4 digit. Okay, then alphanumeric display. Like that, you have a different type of displays. For that, what you have to do, you need to go through the data sheet, then accordingly you need to give the connection. See, these are all different types of 7 segments. So here there is a limitation. I will show you in the second slide. You can create only few characters. In between you can't create X. How you will print X? It is not possible in this 7-segment display. Only fixed character you can make to. See, this is double digit. Likewise, you have a n number of versions. Day by day they are introducing new things. See, this is 3 digit, and this is your 4 digit. So for your project, what you want to do, see here in a single fabrication, they made everything to work perfect. See, number of pins very minimal. How segment selection also, you study yourself. Okay, If you have a doubt, you come back. That's all. Sir, in the task katilama, sir. Sir. Yes.
Yes, Gajendran.
Yes. So the limitation I told no. See, in this here I made it to print some value in the title day. If I put capital letter D, it is not possible. So I made small letter d. Then task. Actually, this is not a 7-segment display output. Okay, I printed something using the word print option. So these are all few options, few limitations with the 7-segment display. In the market, you have 14 segments to display also available. If you bring those LAS displays, you can create more number of characters. DAY-10 task, please note down the question. Design and implement a single digit manual visitor counter. See, we are not included any new project. Logic, everything is same what we have did in the visitor counter. Actually, we taught the same thing in the class also. Here, you are going to replace this with the display unit alone. You are going to change. Please observe this animation. Please observe this animation. Yes. See, there are two push buttons we have used. One is for up count, another one is for down count. So initially it has to show the display value as 0. Once I increment the button, the value has to increment step by step. Again, here the limitation for the up count is digit 9. After 9, I can't increment the value. Okay, so I need to limit the count maximum of 0 to 9. See, beyond 9, if I press, it won't get increment. Then see 8, 7, 6, 5, 4, 3, 2, 1. Beyond 0, if I press also, it should not decrement it beyond 0. So these things we have taught you already. The simple thing, you are going to replace your LCD with 7-segment display. Okay, that's all. So if you combine your previous task, so 0 to 9 count we taught you, that experiment and your previous visitor counter experiment. If you club these two, you will get this output. That's all. If you have any question, please ask.